start with a record. Then we can start with our main subject. Okay, the goal here is to talk about secure and efficient communication scheme for remote virtual surgery. We'll talk in general about to introduce something first about this issue about medicine. And then after that, we can go to the theoretical issue about this medical medicine scheme. And then after that, we will show some implementation and results together in general. And then we go to analyze and discuss about this issue. And then we conclusion for some future work, conclusion and some future work. So I hope you enjoy. Keep in touch with me, and if there's any question, please keep it to the end of the seminar. First, we will show some highlights about this issue. So, first, the patient in the rural area. The patient in the rural area actually need a medical services, need a good medical service. But we cannot provide this option for him because rural area is difficult to provide a good medical service because it will be cost effective. At the same time, it will be difficult to send a good staff to the rural area. Then telemedicine coming as a good solution, as a promising solution for these obstacles. To improve the medical staff by give some lecture or sharing surgery and so on, and also to improve the equipment issue. In the rural area there is a poor equipment in the medical rural area. So remote virtual surgery, it is a part of the telemedicine. We use it to improve the skill of medical staff, at the same time improve the pool of equipment by using virtual technology. We motivated after coronavirus, of course, because it become like urgent need because there is too many epidemic area, isolated area. So if there is too many isolated areas, this isolated area needs medical services, and that can be only happen by using telemedicine or something like this. So telemedicine coming as a good solution for this epidemic or isolated area or region. Then we proposed a new scheme. We proposed or designed a new scheme for this issue. We proposed a scheme to improve the efficiency and the security for the 5G networks, which is used in a remote virtual surgery in general. How we improve efficiency? We improve efficiency by using a swarm strategy or swarm approach to find a good network so it will be more fast. And we improve the security by using electric care detailment, by using cyber security, which is more secure than internet security or soft security or application security in general. Like now, cyber security become the most used now. I hope it will be clear. Now I'll jump to another slide to show the graphical abstract for our idea. First, we can see here surgeon is expert surgeon here. He wear virtual reality and he has a robotic arm like connection, like terminal. Then he sends signal through the network to the medical staff. And this is the poor medical staff in the rural area. So to solve poor equipment, we're using image processing and send medical records for the patient and medical image and so on, X-ray and so on between two terminal. At the same time, like you can advise them how to make the surgery. You can share the surgery with them through the distance. How we do that? How we improve this system? We using, of course, we have a 5G network. This is 5G network. 5G network. It is not nothing more than wireless node and connected with a ad hoc node network. Ad hoc network is a fast network actually, but it is coverage area. It is not so wide area. This is why we needed to connect with a non-structural network. Non-structural network, it is wireless network suitable to be non-structural network. And then in the other side, there is an ad hoc network. So together, ad hoc network and wireless network together achieve a 5G mesh network. So this is the 5G network. It's not nothing more than wireless and ad hoc network connected together. And how much we put node inside, how much will be more like too many choices to reach a specific point and improve the services. So this is the main structure. And what we do, what is our touch here? Our touch here is like when send the information from the surgeon or to the medical staff, we use a strategy to find the fast path. As we can see here, the green one is the fast, the fast one. So how that happen? By sending the test signal for all nodes by using what they call it swarm strategy. We send this test signal, and the cost here of test signal represents a throughput. So we send we send throughput test signal for all nodes, and it can tag to the main station to check which one is suitable path. And here is the green one is the suitable path to send. It's the fast path to send to another and receive. And then after that, after achieve this decision, we secure it by using cyber security strategy, which we will talk about it later. This is the remote virtual surgery in general. You can see here, like it will be go to the 5G mesh network, and this is 5G base station, and this is our flow, which using a deep learning, or we using a swarm. There's two strategies we use it already. We try to use deep learning first, then jump to the smart, or say it's like a swarm strategy. Then after that, connect to the base station and to the router. They connect to the medical staff. And then the image sends its X-ray and some other medical image. And of course, we can see like visualization things. Like for example, we can show the tumor like as a virtual point or something like this. It's better than like show the image without any declaration. So we're using also virtual reality facilities to show tumors and so on. This is the machine which is already like full, so we just want to improve the network in this machine by using by add the middleware which is suitable to improve the network. This is the surgeonal part, the terminal. He can send and see the image and send the signal, and then it will be go to the surgery room. Then there is one staff. Let me give permission for someone else. Then you can see here, we have robotic surgery, and there is a robotic arm system can do the surgery. Okay, what is the challenge we're facing? In general, the surgeon needs to get information from the patient in real time, and this is one challenge. The other challenge is like the surgeon, the expert surgeon needs to communicate with the medical staff in the real time. And then the remote virtual surgery must have a secure session between the surgeon and the other medical staff. What we do to achieve this one, we do some objectives to improve this obstacles. First, we improve the remote virtual surgery by designing an emergent scheme. This scheme has we enhance the efficiency by using this SWAT strategy, and then we improve the security. Improve the security by improve the cybersecurity, sorry, by using elliptic curve helmet strategy, and it is used on the fragmentation part in the network there. So it will be like a cyber security strategy because it's already used in the in the network layer in the TCP/IP protocol. Some other studies, they using Da Vinci, Walda, but it is like low efficiency. It's not very good. And then also they're using body sensor, WAPAN and DBMA, but there is no method. They don't have any method to improve the efficiency. And then other using HMO and CATRC, but it's weak method. It's not so good. Vivo also is not so good. And then about security, they're using Bluefish and the other like AEC and some other methods, but it actually it is used in application layer. And you know, application layer is easy to break. It's not like cybersecurity. It's not like you use security in the network layer or middleware security, which is more secure because it's difficult to access by attacker, by the man in the middle. Then their study finding focusing on implementation, a simple method in general, some others. And the others, they improving the data encryption and decryption on watermark and so on, watermark technology, which is not suitable to improve the security. It's not good stuff. So compared with our work, we use a fast network first, 5G, 5th generation wireless network, and then we use a swarm on this network to make it more faster. And we choose a swarm because it is suitable for unstructured network, and we need unstructured network because we don't know exactly the how to say that the region we want to send the signal for them. So it is, you know, it's not suitable to focus on the structural network. And about security, we use cybersecurity, which is the best now to use, and we employ elliptic curve helmet, and we employ it on the fragments, so it will be more secure. So here we're using two methods: elliptic curve helmet, which is 40 of security, and at the same time we implement it in the embedded layer inside a network layer and between network layer and transport layer, something like this. I hope it's clear. This is the methodology, and I will jump to the theoretical study. First, we improve the efficiency, as I said, as I mentioned before, we use a swarm approach. What is a swarm approach? A swarm approach is a method used by like ant colony and so on. They send the cost and they send back with the result. And depending on the result, they decided which network is the fast. It's a strategy to find which network is the fast. It's not to improve the line between surgeon and medical staff, but it's to choose. It is method used to choose the suitable path to connect. And then about security, as I said, like we're using electric security helmet, all the fragments, secure the fragments send and receive, not the data. So we secure the access, not secure the data here in this part. We can see the proposed remote virtual surgery, which we already implemented. This is the surgeon in the another region. They see main hospital. It is the mesh point here, and all the terminal here is connected with this region. And in another region, there is another mesh point connect the medical staff, and together they connected through the mesh partial point to connect to the switch, and this switch connects to the access controller to control the traffic through the switch P. Here switch P is like catalog, we'll say cat 3 or something like this, and then connect to the internet. And this is the surgeon, this is the robotic system. Okay, so the first main work we do is to improve the network, to improve the efficiency, to find a suitable path, Okay, so to find the suitable path, we use this network. So it depends on the cost, and the cost here in the method represents the throughput for us. So for example, as I accept this one, I make it one by one is better for me to ensure that the people who's coming. Anyway, so as I said, we improve here the efficiency. Then you can see that to improve the efficiency here, we improve the cost. We find a suitable cost, and suitable cost here the throughput for us. So for example, we have several mesh points, and this mesh point is responsible to make a coverage area for what they call it is different region, but it connect with each other through MPP, which is like mesh partial point, and of course it connects with the access controller, which control on the network in general. So, for example, hospital 1, if want to connect with a hospital 2, let me highlight it. Hospital 1, hospital 2. For example, hospital 1 wants to connect with hospital 2. It will be find the suitable cost. For example, check hospital 1, check hospital 3. Then it will be retained through this routes, and will be find a suitable path, suitable what we call it, suitable routing path, by using this method. So it will be connect our next session with this path. For example, here, for example, hospital 1 using swarm strategy, find this path as a suitable path to connect. So it will be achieve the session between hospital 1 and hospital 2 through this connection and close the session. Then after that, achieve security. I hope this is clear. And there is another slide to show how it works. We have a strategy to find a real throughput by using window size and RTT, like round trip the time. It will be sent from the source destination node. So we can see here this path is this path. I think this path is the suitable path to connect. Then it will be achieve this path to connect. Then it will be achieve this path to connect. Then it will be achieve this connection, this session, and block this session, and then after that it will be secure. How we do that? By using a swarm strategy. Depended on what? Depended on the throughput. Because we send the throughput for all nodes and find which path is suitable, which path has the lowest cost, has a high throughput. Then we connect with this path. Okay. Let's jump to another slide. Okay. The swarm states. Okay. Let's go to see the swarm states. First, we define the numeric, let's say, the variables in general and function. Then after that, we send the test signal for all nodes, as I said before. Then after that, we define and calculate the swarm parameter by using a throughput parameter. And then after that, we find which one is the highest throughput, and they connect it with this path. Then after that, will be achieve this session, and then go to the security path after finish this. The main second work, and we will go to in details later. The second work is to achieve the security. And to achieve the security here, we have a hidden layer here, what they call it cyber security layer here. So it will be go from the application layer, after application layer, it will be go to the TCP here or UDP. It will be segmented, and then after that it will be segments. Then after that fragments by add a segment ID for each one. And in this part we will add something extra. It is middleware. It's not a program. Middleware it has, how to say it is inside the network. It is inside the program, embedded the program. It is not like an application layer program, not application layer program. So it has a capability. We use a Python at that time, and we use a Scap library to reach this point, because it's difficult to reach this point in normal programming. So we reach this point by using the Scap library, and then we embedded this ID. It is the key of electric element. So we encrypted here the fragments, not the data. Then after that, it will be go to the trailer, and the trailer it will be send all the MSS to the other side. In the other side, there is a hidden elliptic curve element block to this decrypted. Then after that, we will see the information the right. And this is the strategy. Of course, elliptic curve element have two parts. First, the elliptic curve, which is like strategy, graphical encryption, by using this equation model to find a XY point in the graph to be a key, a secure key, and then after that connect this with a four public keys, send and receive, two public keys, two private key and two public keys. And this is the element part, which is after achieve the connection, it will be send a public key for the surgeon and public key for the staff, and this is the through the way, and each part keep the private key, and depending on the private key for each site, it will be open the security outside like encrypted and decrypted by using a private key. But the same in the area, in the media, it will be sent a public key, which is not so important, which is not so active if you don't have the private. Then this is the trailer, and this is changed in the trailer. In the trailer, we change this two parts. We modify this two parts by using Python, as I said, and using Scap library. Then we go to this trailer, and in the trailer, before we send it, we modify this two parts by using this code, by using Python code. So we modify this part to improve, to find the cost, the suitable cost, and use it. And then after that, we improve the fragment identity by how to say like put elliptic curve Hellman encryption rather than normal or classic identity, like it look like an index. So we modify this two parts. This one for throughput and this one for security in the trailer. And the whole trailer, you know, all of us, you know, the structure of trailer. This is network configuration at that time when we configure the mesh point and mesh partial point. Of course, you know, it will be like segmented and segmented by depending on the number of bytes. So it will be like IP address and some bytes for same data, and it will be different from the device to device. So each device, depending on the type of device, will be like different size of bytes. So you have this number for the point-to-point segmentation to be 276 bytes, and there is 20 for IP address, port source and destination, and so on. Offset we have index and so on. And this is the graph to show how we achieve this one. So first we have a size of data, and we have a 20, like I highlight. We have this one, 20 for the IP, and this is the byte thing. And then we have the block for elliptic curve Hellman, and then this one in the network layer, and then it will be sent to the segmentation diagram. This is segmentation diagram for the middle between routers, and also it will be different number of bytes, will be segmented more, and then added with the IP 20 bytes, and then embedded with the elliptic curve Hellman, and this is several flags. And then it will be sent to the terminal, also changed to this size, because the size of segments will be changed here, and will be added with a 20 bytes for the IP, and then the decrypted, the security element, and then go to the hosted to the medical stuff. This is the fragmentation diagram in general. The segments first, the number of segments, then the ID, then the search, and then some other flag, and then offset. Okay, so let us go to the third main work. The third main work is we improve using deep learning, improve the surgeonal stuff. So it could be easy to use his mind signal and control on the robot, and also you can use hand. So you can see here Link 3D, which is like some other programs using to connect with the virtual reality and robotics, and then send this signal to the terminal, other terminal, and send some feelings, some surginal reaction, and so on. And this is a scheme to show. First, we can get the signal from the mind, from the hand, then it will be go to the dingle, and this dingle will be sent to the virtual reality, and then to another terminal. And this is the neural network. And in general, this is a signal coming from the mind, from the hand. It is analog, and then it will be processing by using, I'd say, multiply by pulses. Then it will be segmented to be like processing the signal to make it discrete and receive in another side. Implementation, we have here like mesh point. This is the Hawaii mesh point. We already programmed this, and this one also configured. Sorry, we configure mesh. This one configured, and then we have access controller also. We configured. Then this MPP connected to the access controller to send controls to the and internet to the mesh point. And then we have two terminals. This is a surginal terminal that is highlighted. This is the surginal, surginal terminal, and this is the medical staff terminal. Medical staff terminal, this one. Then it will be sent and received using this mesh point. We have this mesh point and this mesh point. So we have already we built two networks, and this two network connected with a MPP and connected to the access controller. And there is too many roads and after access control through the internet, and it will be choose the suitable path, then it will be achieved the security. Then also we connected with the to show the implementation results. You can see that this is the region 1 for the medical staff, and you can see that this is the MP. This the MP responsible about this region, and we have this MP responsible about the next region. And with this one is MPP. This one is MPP to connect the two regions, and the catalogs. So I say cut 3, cut 6. This one it will be connect with the access controller to control the packets, send and receive the whole trailer, and will be connected to the internet, as we can see here in the network. The configuration for network, first we define the AP1, AP2, and AP3 as access points, and we defined as China 1, China 2, China 3, and here is NTP. The China 3 is the NTP here. Sorry, China 1 is NTP. This one is NTP. And then is MP and NT, and then here's the access controller. Then we have mesh points, mesh partial points, which is connect with the internet, and we have two mesh points for the two terminal, and then we have access control on the packets, and this is the type, and this is my network for each one, as you can see here. And of course, it's virtual LAN, and give the name 100, and we give password for the network, and we build this network in general before we start to achieve our project. And this configuration also for by using catalog, by using control terminal language, I'll say like configuration terminal language, something like this, configured by using rollover with each access point. Then we configure it. by special configuration. In this case, like say, like we have a VLAN and we connect with the data. We change this configuration using a hyper terminal. The result we get it in general, as you can see. Let us explain this key. First, we have China 2 and China 3, which is MP1, MP2, and then it will be send the signal. For example, here, China 2 sends signal and China 3 sends signal through the access controller to the internet, and then the network the middleware finds that China 2 is the best path to connect. Then it achieves this connection, and in the next slide it will be secure. How the network, how the middleware know this one is a suitable path. They know this one is a suitable path by depending on the channel throughput. You say like throughput. Then the first one gives a throughput 12, and this one is 14. Then 14 is higher throughput. This is why it make it. This throughput is more better than the first one. Then China to become a suitable network to connect, depended on the throughput. Using the swarm strategy to calculate this one. Another part, like secure this part. So after achieve this connection with China 2, we find we calculate electric currency element keys, which this one the X generation and Y generation, and after that, as highlighted, we have this key and this key, which is the encryption key, and this is a public key generated, then send the public key through the network to China 2. And in this part, there is a private key. Depending on the private key and public key, will be open the encryption. And the other side also has another private key and public key. And depending on that, depending on this private key and public key, it will be secure. It will be secure, the session. Okay, this is the configuration panel. Actually, we work on Python. Python is better than, we work on Ubuntu, which is Linux. So it's better than Windows when we deal about, as we know all, when we deal about networking and configuration and how we enter inside the network and like how to deal with the other layers like network layer, transport layer of TCP/IP. When we deal with these issues, it's better to work with the Linux or Unix, which is easy to access and to configure, better than Windows, because almost Windows is closed, not open source. So we use in general Linux or Unix. This is why we use Linux here, because in Ubuntu we have a library, they call it Stack library, so we can easily control on configuration or change it or reconfigure it. So in general, we can see here we have China 3 and China 2 configuration, and we can see here we have an IP for this one, and we have before routing my network. This one is this one, my network, and the packet and so on. I don't think so. I will accept more after this range because it's nearly to finish. Okay, so this is the configuration for the network. This is the code that we write. You can see that the result, and we can see here you can see here, like our throughput after connect, after send all the throughput for all routers and return back with the result. We found the throughput one come return back with 14, and then throughput 2, 12.9, and then after that the network find that to connect with the center one is better, because the throughput is 14, which is like mean highest throughput, mean number of packets sent and returned back more than other networks. I hope it's clear. In question part, if there is any installation, we declare it. You can see we try this several times, like 10 times, but like we just show some main trials. You can see here, in this case, we have near the part center one, we have 17 megabits per second throughput. In this case, the suitable connection is with center one, and this case we have 13. When we change the places, and then it is, how to say it, like center 3 is suitable, and the other one is center 2, and we find the suitable one is this one, the center 2. About security issue, you can see that we send APC, ACDP, APCD. We send APCD as a test signal. Then after that, it is packet to become ACDP, and then send it to her ICDB as like this one. You can see here send APCD. Then it's encrypted to this one, like change the fragment and encrypt it to this one as an example. Then it will be sent. The other side it receives ACDB, and then change it to APCD. Of course, there is a code inside, an encrypted code and handshaking, but I just show the result. And there is another example similar, like send it ESTH, and then after that will be changed and received. Then here we can ensure that it received the right message. We just have to check and ensure as a test signal that we receive the right message. That one also to show how the security part. You can see that we send it with a public key. You can see the surgeoner public key. Of course, we have a private key inside, and the surgeoner choose the private key, like for example 33, like I highlighted. First, the surgeoner choose the 333, then it will be changed inside the calculation and get a public key, which is X and Y. Then what we said before, then these two numbers will be embedded in the fragmentation and send it to other side, as you can see here, the same. So it receives the same public key, and also we have a private key in the surgeon and the medical staff part, and depending on the private key and other equation, like in the middle equation between the medical staff and the surgeon, depending on this equation, we get also we can encrypt another public key from the medical staff. So we have one public key from the medical staff and one public key from the surgeon staff, and will be sent through the network, but without a private key, from the to terminal, we can't open this to get this secure key. So this secure key, as we can see that it is the same. We can see that this secure key is the same. This one and this one also. What is the secure key? This one. You can see the same secure key in two sides, and this depended on the public key, two public key and two private keys achieved together the security between the surgeon and the medical staff. And this other example, you can see that we have a surgeon private key. We get a private key. We choose the different cases, different case 1, case 2, case 3, 4. We choose different numbers and we get different results. As we can see here, we get different results that have changed the colors suitable. We get this one for X and this one for Y in each case. And then robotic key, the other side key, the robotic system and medical staff key, also private key, different, we choose it. And also we get a different, different X and Y. And then in the end, we get from all the private key. This private key is the same in two parts. Okay, the analysis and discussion. You can see that in the first case, it will be sent randomly, which is not suitable because it will be more slow, and maybe there is a breakpoint in the way, so it's not suitable. So our strategy depended on this timing diagram. First send this signal, the throughput signal for all, and depending the base one, we will send the information and to be saved the time, the tau. You can see here it will be like different tau between the normal case to send and our method. You can see here different tau. It's maybe to be the half. So in this case, we improve the efficiency of the network. So we can get a more efficient connection. Then we can see throughput also in this graph. You can see the case near the center one. We find this case. This case is suitable, and then this one is suitable, and this one is suitable, and so on. Okay. About security key, you can see here it's difficult to estimate the security key. It is so difficult. It is nearly to be impossible. And the green one is the security key, as you can see here. This one is the security key, which pulled from the blue one, which is the public key, and the red one is the private key. Together, we get this green one, which represents the security key, and it's difficult to estimate. It's difficult to get it by a man in the middle or hacker or something like this. About efficiency, different place, different efficiency, as we can say. For example, let us take this part. Like for example, 11, you can find, for example, here China is suitable to connect because it's highest throughput. In the other case, like in different places, 9, it will be China 3 is better. So depending on this graph, we can decide which one is better. And also you can see here different places for private key. Also extra slide to explain that the encrypted key is so secure. Conclusion and future work. In general, we make three main work. First, we improve we try to solve the communication obstacle and solve a bottleneck for the robotic surgery 5G network. Then we do three main work. First one, we improve the efficiency of the network on transmission. By using this one, we improve the security by using a cyber security strategy, and which is mixed between how to say it, like between electric curvature helmet and segmentation ID. So we embedded the security inside the hardware to make it cyber security. And then in the other side, we have a terminal on the two sides, like surgical side and the medical staff side. And there we we improve the virtual reality issue, how to send and receive medical reports and image processing by using virtual search, virtual vision, and how to send and receive the information, and improve it by using deep learning. So the performance analysis, demonstration, and proposed scheme is trusted and efficient in the end. Future work in general, first we try to improve the distance learning. You know, it's going already now, almost the knowledge is going to be online because the epidemic and so on. So in general, it becomes difficult to make a surgery in the rural area, especially if it is isolated area. So we try to move to the online surgery, and the world here in general go to the online services and telemedicine. This is why we try to improve it by improve the virtual reality tools in general, the communication environment in general, uh, like using another security method, and so on and so on. Thank you so much. Thank you so much. I'm so appreciate from all for listening and